Try not to electrocute myself. This will be MIDI controlled as well, so we can turn it on via the console. It's pretty good, isn't it? So as you just saw in the last organ video, we got the whole Compton tone box thingamagoop music machine playing via MIDI. Finally, all of the ranks and all of the stops are wired in to be controlled traditionally by something like this, as opposed to having that massive cable loom that if we wired into this, if we needed to move it again, we would need to chop it off again. It's a silly way of doing things, but with the MIDI cable, it also means we can control the Compton organ with other things. For instance, MIDI files, because I'm not an organist myself, or synthesizers or synthesizer sequences, and everything that is in between. Anyway, before we continue wiring in the bits and bobs into the MIDI matrix for that thing, for instance, turning on the motor and stuff like that, I figured it was a good time to actually jump onto the other part of this project. This is a Compton's Organ Limited console. It is the thing that controls those spinning tone wheel thingamajigs. This one looks extremely similar actually to the Makin. It's pronounced Makin, by the way. A lot of comments were like, oh, you've got to pronounce it like that. So there we go. Makin. I'm sorry if I do pronounce it Makin. I'm pretty rubbish with words, but anyway. It's over there. But if you look at this picture right there, you'll see that it's very similar. Unfortunately, like I said in the last video, it sadly got scrapped. Lucien Nunez, who managed to recover the tone wheel thingamajiggy over there, was going to try and get the console, but sadly I think plans didn't happen and then it ended up having to get scrapped, which is a very sad situation indeed. Anyway, not all is lost because we got this beast. So this console is also from Lucien's collection. He got quite a few things from Lucien Nunez's collection. It got shared between different museums. If you don't know, Lucien Nunez spent a life collecting a very large collection of things and electronical machines, with an aim later in life setting up a museum called MEAT, Museum of Electric and Electromechanical Technology. However, very unfortunately passed away a couple of years ago, but this meant the collection got dispersed around. He had an incredibly large collection of Compton organs, and they've gone to different organ museums. And actually on the last day when I went to the warehouse where he had his collection, this was actually still sitting there. And it turned out nobody was picking it up, so without thinking about it, we took it on. This console was situated in Glasgow, and it actually comes with its own wooden tone wheel cabinet, which we do have, and we're also planning on wiring this into that as well. The idea is both of them are plugged in for a wider, fatter sound. Because if you think about it, the one that's over there, for instance, even though it has multiple banks of tone wheels, it's all being controlled by the same motor, so everything is intrinsically synced, which means you don't get any oscillator phasing effects that might make it sound a bit fatter. So the idea is if there's two Compton tone wheel banks, well, it'll just sound a bit more chunky. It might even sound a little bit like a synthesizer. We'll have to wait and see. But first, before we even think about that, we need to get this talking to that. So this actually varies to Jones organ because the pedal board doesn't actually have any electronics in it. The electronics are down there. One sec, I'll just get it out of the way. So this is literally just wood and springs and levers, and it pushes down like that. The actual electronics for the pedals are at the bottom of the console, which is different to Jones organ, obviously. Very interesting. Oh, lovely. Make it a little bit lighter. Oh my God, every bit of wood on it is heavy. Right, let's see if we can move it. Oh, for God's sake. God damn it. Oh yeah, right, we're on the back of it now. The business end. Around the back, you'll notice that there isn't a crazy amount going on. There's obviously still stuff going on, but there isn't as much as, well, I would expect. So let's look at what we've got. Right, we've got these things that resemble some sort of latching memory thing. I'm not particularly sure. Maybe this is a converter for getting pedal to grate or stuff like that. Not really sure. It will make sense. So this is swell. This seems to be maybe the stops. I'm not sure. Don't know. This is the back of the preset panel. You may remember in the last video we had a look at what the preset panel is, which is actually visible. You can see it from just above. So here's the preset panel that was hiding behind the panel right here. So we lifted that up. We saw the presets, which is for the buttons. Those buttons that are underneath the keyboard. There's the back of the stop switches. the stop pistons, stop plungers, or whatever you want to call them. So these can electromechanically pop in and out, so that's cool. Down there, there's a power supply. I'm going to assume that is a 24 volt power supply. It's a chunky boy. There's a couple of big boy capacitors. So hopefully we'll be able to just power this up. 1.4 watt. So this is the back of those pedals. Multiple, what in God's name? What the hell? That is insane. You see that? You see how that works? So you see that bar is kind of slanted. So the further it gets pushed down, the more of those contacts the bar actually pushes on. So it's literally a resistor ladder. That is insane. That is mental. That's crazy. I'll try and figure out a way of describing that when we work on that, because if you don't see what I mean, that is really cool. That is well funny. I don't think I've seen that before. There's another example of it. Look really closely. When you're pushing on them, they go push down. Maybe this one's easier to see. That's mad. Oh no. It's one of those things where the more I look, the more the plan is getting more convoluted. This you'll recognize from the other one. It's gonna hopefully largely line up, but that looks dramatically different actually. But we only need to worry about getting it converted to MIDI. If it doesn't all line up to the one that we're midified already, it's no biggie, because we've got the actual tone wheels that fit with this console. So anything's a win. Luckily, you'll see that it's actually labeled. So spares, pedal. Okay, so so these ones are spare because there's no wires connecting to them. If you look at here, these ones have actually got solder on them. So these are connected to the pedal. So that's the pedal keyboard. That's the choir keys. That's the great keys. That's the swell keys. Much the same as the one on the actual tone box. And then we've got all of the stops, luckily labeled. The top things are all the fancy functions, like turning on the rotophone, which is the spinning speaker, various different speakers and things like that. Enclosed, pedal enclosed, rotophone, don't know, we'll see what that all is about. So we've got swell stops, tremulant, and these are all the pull out pistons on the front. We've got the great pull-outs, we've got the choir, and we've got the pedal switches. They all connect together. We've got pistons, okay. So this is all of the presets. Hopefully we don't even have to integrate with this, because in my mind, I think everything that is being dealt with the presets is actually being done in here. I really blooming hope so, because that's going to really complicate things if not. So there's that. Yeah, I don't actually know what that is for yet. Haven't got the foggiest, but it will all make sense. But there is a box here. This is weird because I don't know what's inside that box. Something tells me it's memory, which you might be surprised to see in an organ. Now, I might be completely wrong. This might not be the memory whatsoever. I do not know. By organ memory, I mean there are usually grids of latching kind of bits, ones and zeros that latch and remember where they're supposed to be. It's quite insane, and it's hard to describe until you see it, but I'm hoping that this is what's inside this box. If not, then it's anybody's guess what this is. Oh no, it doesn't look like it's actually anything. Oh no, there's something in it, but I don't think it's memory. What is in here? Oh, what the hell? What the deuce? That is amazing. So this stuff obviously does something for the console. We will inevitably find out as we tinker what exactly it is. It's probably obvious to people who have already worked on it, but you have a look at this one. This is quite interesting. So there's a coil, it pushes on this, and it's like an on and off. So it's basically it halves the motion. So you see one click, it turns it on, one click, it turns it off, one click, it turns it on, one click, it turns it off. Initially, I thought it was accounting like a uni selector, but it seems to be a sort of on-off flip-flopping kind of thing. Here we simply have a bunch of relays. They're all a bit sticky. What they're making connections for is anyone's guess. There's also a separate row of relays around the back. So that's not the memory, but I've just seen another box. There's another box. Is this some of the organ memory goodness? Maybe it is. It does look a little bit more like a box that you'd see the organ memory kind of stuff in. So let's lift this up. No. What in God's name is that? What the heck is that? So we got even more weird shapes and weird thingamajigs. So this is like, what the heck? Okay, interestingly, it's like a normally open and normally closed relay all in one. So you'll see at the bottom, some of this is underneath and some of them are above. So as it breaks a connection, it also makes a connection. So there's some weird relay logic going on around here. Okay, interesting. There doesn't seem to be any of the memory that I've spoke about. In fact, there is some over here. I'll just quickly show you it because I don't want to ruin it and say, oh, we'll show you later on. This is literally like a latching, addressable kind of grid of memory. There's a bunch of coils at the bottom that pushes down, and as you can see, that sort of resets it, and then this will write it. So it pushes along. I can't do it with both hands, but I'm going to make a project with these. We'll talk about that later on. But memory, or literally before computers, organs had addressable memory. These are obviously multi-switches, but what they are for, swell to grate. Ah, they're the converters. There are some stops on the front like swell to grate, which means when you pull that out, that means that two of the organ ranks are controllable by the same keyboard. I think that's what this is. This literally connects the keyboards together via a big multi-contact relay thingamajig. So it's perfectly fine and understandable if none of that made sense. It barely makes sense to me right now. But fortunately, what I'm seeing is, I think, what I'm expecting. So it feels like it's going to be going to plan. So if we get power to go down to here, potentially we'll be able to see it do stuff without having to modify it or get it wired into the tone wheel. Because all of the memory logic for the presets and things like that are being taken care of in here with all of this fancy gobbledygook stuff that we'll see what they're doing when it's moving. So what we need to do is get some power into this and work out what the fudge it is doing. It's maybe AC because these look like diodes. So this is probably a rectifier. So it's receiving AC voltage and being turned into DC voltage. And then this transformer is bringing it down to the label down here says 23. So I'm assuming that's 23 volt. There is likely a reason that these got too hot and broke off. So ideally we need to push this a bit further away to start with. But this is seized, so I'm just going to keep an eye on it for now, and we'll have a look at the temperature when we get it all plugged in. Get this soldered back onto, I'm assuming there. It's going to need a lot of solder. Let's get that done now. With the power supply down here, we've got a big transformer that I think takes big voltage from these three wires right here. This green one, this red one, and this black one. That travels over via all of this wire over to down over here. And it's those first three. So we've got to work out what voltage goes into that. So it does say 120, and that is wired into another one that's 0. And then there is one wired into another 120, which when you add them both together, that's 240. It might be 120 volts. I don't want to assume it's mains voltage. So I'm going to put a little bit of voltage in first, measure the output, which is here, which should be, if we look carefully, 23 volts AC, that then travels up into these diodes, which make a rectifier. Then these thick ones presumably send out 23 volts DC via this to the whole machine. You know what? No, I'm going to deduce this is actually mains voltage, because we got the black one, which is the neutral, that connects to 0. And then we've got the red one, which is the brown, the live, and that connects to this 120. Down here it actually says 120, but then the 0 goes over to this 120. So that's adding it together. And then you got the green, which is the earth, the ground. Got this kettle lead. I've cut the end off. And we're going to plug this in. Oh, minus all of these cobwebs. And then the earth, and the ground, and earth into green. At least I blooming hope so. Right, the moment of truth. There's no time like the now. Why did I flinch? It's the idea of it blowing up next to me, but it won't. Oh, god damn it, it doesn't work. Okay, that's good news. We're not actually getting to here. So we need to work out why the voltage, the power's not getting over here. Oh, aha. Okay, I'm following the wires up and they're going in there. There's a switch hiding just over there. Oh dear. Now where is that going? Oh, what? There's a fuse thing. Oh! Now, I know what you're thinking. We could probably just shove a couple of wires between those fuses, but I know for a fact I've got some of those, so I'm going to go and find them, plop them in, and we'll carry on from there. A few moments later, and I have a couple of them with a couple of different types of fuses. Going to go for the big boy one, why not? And plug it in. So this is the usual kind of fuse thing for a Compton. So they're all nice and interchangeable. Nice. Now the power should be going all the way from there over to here. So I'm going to plug it in and we'll do the smoke test together. Okay. An idiot. I unplugged the extension cable before I went to go and get the fuse thing. Attempt number 3. Ear in. Still nothing. Oh my god! Oh my god! Look at this. Look at this. Look at this. Look at this. This monumentous occasion. Oh, it's on, and I'm going to push a button. Oh! I don't know if you saw that. Oh, yes. Oh, let's push these all back in, because it seems to be stuck on. Okay, I'll push this one. Oh! Did you see that? What's that? Come on. Oh, no. Oh, no. Oh, no. We're going to turn it off quick. We got problems. Oh, dear. Something's stuck on the presets. Something's got hot, but not irreversibly hot. So I'm thinking there could be something here. Need to give this a blooming clean, but life's too short. Oh my god, that is so disgusting. So let's pull this out. Ah, it comes out like this. Okay, so it's all in view now. Contact cleaner. Yes, it's a brake cleaner. Boop, but pressurized finger boots are pretty damn good. It's not brake cleaner, it is isopropyl alcohol, but they're pretty much the same thing anyway. So, oh. Now I just need to inspect all of these to make sure they're all going up, because these are all in charge, but I think some of them are getting stuck. And it might be as simple as just giving them all a wiggle. Giving them all a good wiggle. Yeah, some of these are really tight, like that one, it sticks down, so got to give it a fiddle. Got to give it a wiggle. I think these are for all of the preset switches, but what happens is the preset's meant to be momentary. If they're pushed down too long, that's why the resistors are getting a little hot, is because they're only designed to be pushed a little bit at a time, not on all the time. Like, you don't have your fingers on the whole thing at once. So these are just like getting a bit sticky. I think it's as simple as that. I'm going to keep on twiddling these things and I'll see you on the other side. So now I can confirm that all of them are nice and free and play and happy. You'll notice that there's banks of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's because there's 4 sets of keyboards. The foot pedals and then the 3 keyboards up there. And they've all got 6 preset buttons each. So there's one there, one there, one there, and one there. And then all of these last ones are kind of like the specialist stuff. So let's turn it on and keep an eye on those smoking resistors. Oh, we've got a light this time. Oh! No smoke yet, which is good. So I'm just going to push a button and let's keep an eye on these. Oh, they popped in, they popped out, and they're not stuck on. So let's push that again. Woo! Preset 3. I haven't done the presets, by the way. Woo! Preset 4. Oh, look at that, they're doing the preset dance. The preset dance, doing the preset dance, doing the preset dance. So you set the presets, obviously, like we spoke about over here. So you'll see that there's 6 buttons, and then you turn on or off. You see on, off on here. You want to have these, all of these stops. So this is the choir. So we've got the choir switches. So this bottom keyboard is the choir keyboard. So we'll go for preset 1. Technically, if we just turn them all off like this. Oh no, that's off. This is a bit dirty. This needs a bit of a clean. Let's just turn it all off. If I pull these all out like this, in theory, if I push number 1, oh, look at that. Okay, not fully working. Those aren't doing it, but that's probably down to the dodgy contacts. Like, we could probably work out why that's doing that. So we'll just pull them all out again. Preset 1. Oh, they're all gone in except for violin diapason and quintadina. So let's violin diapason. That's probably because if you look closely, it's not actually selected. Let's pop that in. And then, so now if we push it again, these should turn off maybe. Oh, they're trying. I can see that they're trying. I'm going to do this. And just see what happens. It just needs a little bit of a wriggle into life. Ah, they're trying. Ah, do you hear that? See that? And we have these lights. As you can see, these are turning on, but these aren't. And these seem to be what sound like they are. So you'll hear it's triggering the on and off switches. So that's the grate and closed. I can't see it. Can you tell me which one it is? Oh, it's the last one. And then there's this one. That one's not working. That one's working. That one's working, but the light isn't turning on. Also seems to be when we're pushing these ones, I can hear a noise going on down here. So here's an example of shared technology. These are, of course, early telephone exchange relays. Pretty cool. So I'm going to push on this. So I'm assuming these two buttons, that one's still quite firm. The lights work on that, but the lights don't work on that. That's because there's no bulb in there. So need to find a bulb for the next time. Crescendo. There should be a light. Oh, this is telephone exchange light in it. There's relays going back there, but there's no light. But there's a lot of relays going on one set. Let me just find where that's coming from. Cool. What bulb is it? Lamp. Sorry, lamp. No, it's a lamp. Bulbs grow in the ground. Right, one sec. Oh, we got it out. It's a yellow one. Yellow, I think, is 24 volts. Yeah, 24 volt. Okay, right, let's find one. We've got 24 volts, but we're actually going to use 45 volts because it'll last longer because it's rated for a higher voltage. It just won't be as bright, but that's not a problem. Right, let's start with the 45 volt one. Plop it in. Give it a push. Turn on the thing and see if it turns on. Oh, look at that. Yes. I think that's bright enough. So we've gone for double voltage just so it's going to last longer. Yes. Wonderful, wonderful. Next thing we're going to do is test all of these things. I will give it a clean at some point, but today is not the day. Right, get these all set to off on the top preset. All off, and this is the pedal. So we've got the pedal, and if we pull all of these out, we'll give it a test, shall we? Right, so. And then the pedal ones are actually down here. I think one's going to be this one, surely it's going to be this one. Oh, look at that. Perfect working order. There's a warm smell in the air. Slight concern. Now we're going to have all on number 2. Oh. This one's a bit iffy. Wood, open wood. We got this one. Okay, I'm gonna get that a bit more on it. Maybe it was me. Oh yes, it was me. So all off on number 1. Are we ready? Oh, and all on, except for Officlidy. Waffaclidy. Oh, that's not quite made it as well. So this is gonna work. Oh, come on, you want to come to life, don't you? You want to do it. You want to work. Oh, not quite. Oh, it did work. It's working. It's fighting against me. So that's good. So all off, all on, all off, all on. So we're going to do the same for this one as well. Right, let's try it now. So turn them all off. Oh, octave and dolce. Nah, being sticky, being funny. They're very sticky, these boys. Okay, so these ones don't open or close, these two. No matter what you push the button on, it's nothing to do with this because I did just spray some contact cleaner on that. Looking around the back, it isn't even the ones that got hot either. So where's it going to be? Well, we know that it's this switch right here that doesn't seem to want to do it, but you can see from over there, that's where the stops are. Here's me pushing on the preset buttons. You'll see that they are pushing, and when you push them, and they make contact. I honestly think it's as simple as they need a little bit more life breathing into them because the octave is just about to start working. You'd see it fighting its way. If you put it halfway, boop. So just need to give it a good old wiggle. Basically just giving it all a wriggle. Screw it, let's take this off, even if it is just for the morbid curiosity of it all. Oh my God, that's a big bite. Oh, that's gonna be awkward. Okay, so it's out. Oh, lovely. So if you can see from here, it's making a contact between this wire that's on the outside and this thing. Look how cool that is. So that's literally the contact making section. Then there's electromagnets that kind of attract and repel it to push it in and out. Just gotta get, oh, that one's free now. That's free as a bird. Okay, it's turning off. It's not quite turning on. Oh yes, to life they come. Very nice, very nice, very nice. Cool, cool, very nice. Let's pop this back in. Right, cool, cool, cool. Fortunately for the bigger picture, it works how I'm expecting, thankfully, so it's all gonna go to plan. All of the systems that are involved with the player using it, thankfully, is all in here. It's not relying on the box of tone cabinets to do any of that. Much like the MIDI conversion in the actual Compton tone wheel box, this conversion doesn't require any modification of any of this. We just need to make a circuit board to piggyback onto the back of this, which are the output pins for the whole console, meaning that in theory, if you wanted to use it like it was originally intended with the massive cable loom that connects all of this, you could, but it also has a MIDI output. So I've got to design a MIDI conversion. For now, let's put it back. Oh gosh. Maybe I'll make a big platform for it because it is a heavy boy. So yeah, we're more in business than we were at the start of this video. All of them seem to do stuff. It's very relieving to know that all of the preset system is within the console, because this isn't something that we're going to be worrying about in the MIDI circuitry. The MIDI circuitry comes after dealing with all of this stuff. Bit of a sticky switch here, that's the thing. Some of it still needs a bit of freeing, but I think over the use and the conversion of the MIDI, it'll all kind of just get less sticky. This one, like I mentioned, also comes with its own Compton tone cabinet. I've done a video and I've just put it up on Patreon about that one. I don't want to blow the surprise on YouTube yet, so if you want to see about that, then go and check it out over there. It's a good 10-minute video looking through the differences of that and this one over there. Amongst a load of other videos, songs, sample libraries, even a VST sample instrument of the Compton organ, with all of its stops pulled out. That is all available over on Patreon, which needless to say supports all of these projects to try and keep these things running, and also the museum that is within open, which you can indeed come and visit yourself. It's open every Saturday and Sunday afternoon. It's called This Museum's Not Obsolete. There's a link below if you're interested in checking it out. But yes, the museum is still made very possible with the kind donation and support over on Patreon, so thank you very much. And if you want to help out a tiny little bit, even just a couple of quid, well, the link is below, and thank you very much. Anyway, I'm Sam, Look Mum No Computer, and I hope you enjoyed the dive into the back of this funky machine. And I'll see you in the next video on this, which needless to say will be talked about at length prior over on Patreon. Anyway, toodaloo-doo, have a good one. Bye!